Horizontal asymptotes depend on the leading term of the numerator and the leading term of the denominator. So consider if we have some function okay, so say we have a sub n, x sub n. And it continues onward. And in our denominator, okay, so where n would be the degree of our numerator and m would be the degree. So n is the degree of the numerator and m is the degree of the denominator. In other words, the largest power. Okay, so we're going to focus. We will focus on the leading terms, right? We're going to focus on the leading terms. This is what we're going to focus on. So, okay, so the first scenario or first case is if n is less than m, right? So here the degree of the denominator is larger than the degree of the numerator. Then the horizontal asymptote, would just be y equal to 0. So for example, suppose we had fx, let's make that fx equal to x to the 4 minus 5x to the third plus 2x over 2x to the 6 plus 5x to the 4th minus 8x. Well, in this case, we just focus in on the x to the 4th and the 2x to the 6th. Well, the degree of the denominator is bigger than the degree of the numerator, so the horizontal asymptote would just be y equal to 0. Okay, the second scenario is if the degree of the numerator is equal to the degree of the denominator. Then the horizontal asymptote would just be the coefficients of the largest power. So this would be a sub n over b sub m. For example, let's say we have fx equal to 2x to the 4th minus 5x to the third plus 7x squared divided by 7x to the 4th minus 2x to the third minus 8x. So here our horizontal asymptote would just be y equal to 2 over 7, okay? It would just be y equal to 2 over 7, the coefficients of the leading terms. All right, and the third scenario, if the degree of the numerator is larger than the degree of the denominator. Then there is no horizontal asymptote. Okay, so when the degree of the numerator is bigger, there's no horizontal asymptote. So for example, fx equal to 2x to the third plus 7x squared minus 1 over x plus 1. So here, no horizontal asymptote. Okay, so there's a little bit of a segue here in the third case. If in the case where n is just one larger than the degree of the denominator. In this case, here, in this case, we will have no horizontal asymptote, but there will be a slant or oblique asymptote. And so that slant asymptote or oblique asymptote would be the quotient of the division. Okay, so the slant asymptote would be y equal to the quotient of the division. Okay, so let's look at an example. So for example, suppose I had fx equal to 4x squared minus 7x plus 8 divided by x plus 1. So here, degree of numerator is bigger, so no horizontal asymptote, but it's only bigger by 1, right? It's only bigger by 1. So there's a slant asymptote, and if I want to find a slant asymptote, I would just divide. You could also use synthetic division here. So I'm going to use long division. So we could have 4x. So this would be 4x squared plus 4x. And then subtract. So these two would cancel out. This will become minus 11x. Bring down the 8 plus 8. And then minus 11 here. So this would be minus 11x minus 11. And now subtract. So these two would cancel out. And then we'll have 19 as our remainder, right? But the slant asymptote would be y equal to 4x minus 11. The quotient of the division. That would be a slant asymptote. Okay, thank you for watching, and I wish you all the best in your endeavors.